There's a lot going on in the Arctic right now, guys. Like we've been saying for months, the ice is melting at an alarming rate, and scientists are scrambling to understand why. But we may have just gotten our first clue about what's really happening up there. And it turns out that the Arctic might be hiding something that could change the world. That's right, something so big that it could literally shift the course of our planet. So, what is this mysterious secret? What does it mean for the future of our planet? And how will it affect us all? You're about to find out. But before we get started, be sure to hit that like button for more videos. Is the Arctic hiding a massive new ocean current that's been dormant for millions of years? Could this ancient current be the key to understanding the recent melting of the Arctic ice cap? And what would happen if it were to suddenly become active again? Well, that's exactly what a new study has set out to find out, published in the journal Nature Climate Change. The study proposes a fascinating theory about what's been causing the rapid melting of the Arctic ice cap in recent years. The researchers suggest that an ancient ocean current that's been dormant for millions of years may have been inadvertently awakened by climate change and is now carrying heat from the Pacific Ocean to the Arctic, leading to the melting of the ice cap. But what does all that mean? Let's break it down. First off, let's talk about this ocean current. It's known as the Atlantic, Pacific and Antarctic Bottom Water, or APABW, and it's one of the largest ocean currents on Earth. Now you may be thinking, wait a second, I thought you said it was dormant. How can it still be the largest ocean current on Earth? Well, here's where things get a little complicated. The thing is, the APABW isn't exactly what we think of when we hear the term ocean current, like the Gulf Stream, for example. In fact, the APABW isn't even technically a current. It's more like a giant underwater river. And instead of flowing horizontally, it flows vertically. And the reason for that is because it's deep. We're talking about depths of around 4,000 to 6,000 meters, which is about as deep as the Mariana Trench. So how does this APABW work, and why is it so important? Well, you see, deep ocean water tends to sink near the poles where it cools the most. This sinking water creates a downward flow that moves deep water masses around the globe. And the APABW is one of those deep water masses. It's formed when cold, salty water from the northern Pacific Ocean sinks down to the bottom of the seafloor and spreads around the globe. And this process helps to regulate the Earth's climate by distributing heat around the planet. But here's the thing, the APABW hasn't been doing its job very well in recent years. It hasn't been spreading heat around the globe like it should, and that's why we've been having such extreme weather events like hurricanes, droughts and floods. The problem, according to the researchers, is that the APABW got stuck in a kind of hibernation mode millions of years ago, and it hasn't been properly circulating since. But now, thanks to climate change, it looks like the APABW is finally waking up. And boy, are we going to pay the price. The researchers say that the recent warming of the Arctic Ocean may have triggered the APABW to start moving again. And instead of spreading heat around the globe, it's dumping all of its heat in the Arctic, leading to the melting of the ice cap. To make matters worse, this heat is likely to continue flowing into the Arctic as long as climate change continues to warm the planet. And that means that the ice cap will continue to melt unless something drastic is done to stop it. Okay, so this ocean current thing is pretty wild. But some of you might be wondering, what does this have to do with the Pacific Plate? After all, we're used to hearing about continental plates moving around and shifting the Earth's surface. But how does an ocean current affect plate tectonics? Well, it turns out that the APABW actually plays a bigger role in plate tectonics than you might think. See, the Earth's lithosphere, which is the rigid outer layer that includes the crust and the uppermost part of the mantle, is broken up into several large plates that are constantly moving and interacting with each other. And these interactions can cause some major changes to the Earth's surface, like earthquakes, volcanoes, and mountain building. One of the main driving forces behind plate tectonics is the heat from the Earth's core. This heat creates convection currents in the mantle, which is the layer of rock between the Earth's core and crust. And these currents are what drive the plates around the globe. But as we learned earlier, the APABW is also a major source of heat in the Earth's oceans, and it turns out that this heat also affects plate tectonics in a big way. Researchers believe that the APABW helps to create deep ocean trenches and island arcs, which are chains of volcanic islands that are formed when two tectonic plates collide. Here's how it works. When the APABW reaches a convergent plate boundary, where two plates are colliding, it creates a lot of pressure and heat. This pressure and heat can cause the seafloor to sink down into the mantle, creating a deep ocean trench. At the same time, the heat from the APABW can also cause rocks in the mantle to melt, creating magma. This magma then rises up toward the surface, eventually forming volcanic islands. And guess what? These volcanic islands form in a chain called an island arc. So basically, the APABW is helping to shape the Earth's surface by creating deep ocean trenches and island arcs. It's also thought that the APABW plays a role in the formation of mid-ocean ridges, which are huge underwater mountain chains that are formed when two tectonic plates are moving away from each other. As the plates pull apart, magma from the mantle rises up to fill the gap, eventually forming new seafloor and pushing the plates apart even further. And the APABW is thought to play a role in this process by providing heat and energy to the magma. So you can see that the APABW is much more than just a deep ocean current. It's a major force in shaping the Earth's surface, and it's likely that it played a role in creating some of the most dramatic features on our planet. But here's the kicker. The APABW has been relatively inactive for the past few million years, but recent studies have shown that it may be starting to stir again, and that could have some serious implications for the future of our planet. See, when the APABW is active, it helps to circulate heat around the globe, which helps to regulate the Earth's climate. But when it's inactive, that heat gets trapped in the ocean, leading to rising sea levels and other climate problems. Plus, the APABW also plays a role in plate tectonics, and its inactivity may be contributing to the buildup of stress along plate boundaries, which could lead to more earthquakes and volcanic activity. Basically, the APABW is like the Earth's own personal thermostat and tectonic mixer, and it's starting to act up. But the good news is that scientists are working hard to understand what's causing these changes and what we can do to stop them. One team of researchers recently published a study in the journal Nature Climate Change that proposed a possible culprit behind the awakening of the APABW. According to their findings, the recent increase in global temperatures may have caused a shift in wind patterns, which in turn affected the temperature and salinity of the ocean water in the northern Pacific. This change in conditions may have triggered the APABW to start moving again, leading to the observed changes in ocean currents and heat distribution. Another team of researchers published a study in the journal Science Advances that used computer models to simulate the movement of the APABW. Their findings suggested that the current may be getting a boost from an unusual weather event known as a Pacific decadal oscillation, which occurs every 10 to 20 years and affects the temperature and precipitation in the Pacific Ocean. Basically, the researchers were able to show that the APABW isn't just some random occurrence, but rather it's part of a larger climate pattern that's been affecting the Earth for centuries. However, while these studies provide valuable insights into the behavior of the APABW, more research is needed to fully understand the phenomenon and its implications for the future of our planet. For now, we can only hope that scientists are able to find a way to stop the APABW from wreaking havoc on the Earth's climate and tectonic plates. And that's all for today, folks. Thank you for joining me on this journey to uncover the mysteries of the Arctic and the secrets it holds. Remember, knowledge is power, and the more we know about our world, the better equipped we are to protect it. So keep learning, stay curious, and never stop exploring. Until next time, this is your host, reminding you that the greatest adventure of life is the journey of discovery.